So in the previous two lectures, we found the mean and the standard deviation of a random variable. Well, now what we're going to do is we're going to look at one, how would changing the random variable by a constant, either adding or subtracting a constant to a random variable, or multiplying it by something, will affect both the mean and the standard deviation, or mean variance and standard deviation, probably a better way to say it. And then we're also going to look at what happens when you start combining random variables. How does that affect things? Right? So here's the situation. We're going back to the Lucky Lover special at the Quiet Nook restaurant. And in addition to that, the Lucky Lover special, which is what the cards are, there's a $5 coupon in the local paper that you can also be adding to the deal, right? So what's that going to do to our expected value and our standard deviation of the amount of the discount? Okay. This is a situation where we are adding something to it. Think about it this way. The $5 is a constant because they're going to get that discount so long as they have that $5 coupon, regardless of what comes up from our Lucky Lovers special, right? The card thing on Valentine's Day. So if that's the case, right, if we're going to say adding or subtracting a constant to a random variable, right, it will affect the mean exactly the way you think it will affect the mean, right? So whether we're adding or subtracting that constant, it will be whatever the expected value would be for the random variable, which could be a few different things, but that constant will remain the same. Right? So we're going to add the expected value is going to, in this case, the amount of the discount, which is what what we're measuring, what x is going to increase by 5. The variance, and as a result, the standard deviation isn't going to change at all, because adding or subtracting, we talked about this at the start of the year, right? Adding or subtracting doesn't change the spread of the data. If we were to kind of graph where all these things are, it would move all of them kind of down the number line, but it would still be just as spread out. The data would be just as spread out. The outcomes would be just as spread out, except everything would be $5 higher, right? So when you're adding or subtracting a constant to a random variable, the variance doesn't change as a result. The standard deviation doesn't change. So putting it in context of the Quiet Nook, right? The expected discount, right? We'll just kind of put discount in there, so that's what we know what we're talking about. Is going to be the expected value plus 5. So we knew that it was $5.83 plus the additional $5, so it would up the expected value to $10.83 without changing the standard deviation at all, or the variance. So we don't really have to show anything with the variance. It's the same thing. All right. The spread doesn't change when you're adding or subtracting something to it. However, when we're talking about this situation, when we're saying, all right, well, if you're going on a double date and you've got two couples and they're on a single check, the Quiet Nook doubles the discounts, right? So it's $40 for Ace of Hearts, $20 for Ace of Diamonds, then Ace of Hearts, and $0 for any black card. We're not going to go through that probability model again. That's the whole point of learning these properties, right? So we don't have to go and recalculate it every single time. But we're not adding a constant. We're changing it by a factor, which is a constant. And so when we have, again, just like we did before, the mean kind of behaves like you think it's going to behave, right? If we are doubling the outcomes, well, we will probably be doubling the expected value, which is exactly what this is saying right here. However, how this affects the variance is important to note. There's a slight difference, right? There's a slight difference. What we would multiply the variance by is not 2 in this case, but 4, right? Because when you're talking about the variance, you have to remember that to find the variance, or to find the standard deviation from the variance, we're going to take the square root. Well, to account for that, we have to square the constant when we're adjusting the variance. And again, we'll show the real examples here, right? So if we're talking about doubling our discount, if the single discount is expected on average to be $5.83, if we double all the outcomes, we're talking about $11.66, which is the original discount doubled. Again, the mean tends to behave like you think it's going to behave. The variance, however, right, would be 4 times, 74.306 was the original variance. We took a couple slides ago, I guess, or previous slide. So now the variance is $297.22 or whatever, out to 3 decimals, which would make the standard deviation now 1724. Now, you probably are looking back at your notes and saying, isn't that just double the standard deviation? Yes, we want to make sure we recognize how it affects the the variance, right? So we want to make sure that if you're trying to find how it affects the variance, that it quadruples it. It quadruples it. Right? So when we're, because I think if I go back a few slides, we could find, I didn't jot it down, but we could find out that the original standard deviation was half of that. Okay. So we've adjusted the mean and standard deviation by adding or subtracting a constant, and we've talked about we've now adjusted a random variable by multiplying it by a constant. What if we start adding them together, right? You might look at this same situation that was just described when we doubled it and say, well, maybe we should not go in on one bill. We should get separate checks and pool the discounts. Would that make a difference? Would that change anything? We'll see. So if we're adding or subtracting random variables themselves, if we're talking about adding whatever it is, in this case, the discount to discount, right? This is how it's going to behave. If the expected value, again, behaves just like you think it's going to behave. However, and this in the notes, we've got 2 examples, X and Y, as 2 different, random variables. This applies to any number of them. So don't, it's not, it just for the notes, we're not going to take it out to 10 or 12 or whatever. You could keep going if you were doing this with more than 2, right? But again, if we're pooling the discounts, we would expect them to be just added together, right? Now take a look at that. The variance of X, either the sum or the difference, we always add the variances. We never subtract variances. That's one of the key ideas in this. We never, ever, ever subtract variances. We only add variances. So in this case, if we look at the real numbers, right, as we anticipated, the mean behaves like we think it's going to behave, and there really is no difference between when it comes to the mean to pooling our either doubling the discount and getting 1 check or keeping the discount as it is on separate checks. We get the same result for our new expected discount of $11.66. But where it differs is this right here. We're simply we're going to add those 2 variances together for the original variance and get 148.612, and then find the square root of that for the standard deviation, and we notice that it's smaller. The standard deviation, when we take the separate checks, is smaller, and that's really an important idea, because what standard deviation measures is kind of risk, so to speak, right? And you're going to have less of it, right? Or it's going to measure uncertainty. Okay? So there's gonna be, the more you have of something, the less uncertainty you're gonna have. Right? So that's really important. We never, ever, ever add standard deviations. Never add standard deviations. Always add variances and then find the standard deviations. Right? That's something you want to remember as well. You never add standard deviations. This is why we want to have the variances available, and we want to know what they are, because that's how we add them. Right? But to further explain why we have we always add variances, never subtract them. Right? It's a measure of uncertainty. Right? Variance measures uncertainty. If we're looking at, say we have a bowl of cereal and there's 16 ounces, on the side of the box it says there's 16 ounces of cereal in this box. It's not exactly 16 ounces. It's about, you know, 2 or 3 Cheerios in this example could change that by a little bit, right? So, but we know it's going to be somewhere near 16 ounces. And say that bowl there holds 3 ounces. Right? So we think that the amount in that box is 16 ounces. But we don't know for certain that it's 16 ounces. Then we're going to take it and we're going to fill that bowl, which holds 3 ounces. Now, we're certainly not going to be so precise that we're going to have exactly 3 ounces. So if we look at what's left in the box, that would represent the difference, how much got poured out. Well, after we pour some out, right? After we poured cereal from the box that we think is 16 ounces but aren't sure into the bowl that is 3 ounces but we're not really sure, we actually poured 3 ounces, right? Are we more or less certain about how much is left in the box? Well, we're less certain because we dumped, we think, 3 ounces into the bowl, right? But we're not really sure because we weren't really certain. Right? This is the stuff here, the adding or subtracting, that's going to take the most practice, because it's really can get really tricky as to what to do with the measures of spread. The means tend to behave just like you think they're going to behave, but the spread, that's where it gets a little different. Okay, so that's where you're going to want to be really paying close attention to things. Okay. So we're going to get some practice now on all of this stuff here, but it's not going to be all together. We're going to try to do something a little different here to see if we can't help keep everybody kind of engaged and moving forward with this. Like I said, we're going to get plenty of practice with this, and we're going to start right after this lecture. So please let me know if you have any questions. Hope this helped.